Hi, everybody. My name is Steichen. I'm a solutions architect at DBT Labs, and I'm based out of Houston, Texas. Before I joined DBT Labs, I led a data engineering team at ExxonMobil, and we created data pipelines on Hadoop, Snowflake, and Databricks. I also spent 5 years in their high-performance computing division, so I understand how difficult it can be to manage data, especially at scale. If you haven't heard of DBT Labs, we maintain an open source project called DBT, which stands for Data Build Tool. And it's become incredibly popular over the last 5 years because it makes transforming data in your warehouse much, much easier. Today, I'm going to give you an overview of that tool and then show you what it looks like using our cloud product. Let's start by explaining what DBT is and where it fits into your data stack. DBT is a development framework that simplifies the way you write, test, deploy, and document your transformation code. It connects to Databricks to facilitate the transformation of raw data from your source systems into published data that can be used to make business decisions. You can think of it as the engine that gets your data out of these bronze tables and silver tables and into your gold tables so that your business analysts can pick it up. Basically, DBT is sending SQL instructions through a SQL endpoint, or now they're calling it a warehouse, to Delta Lake, so that it can transform your data, and it's implementing version control, alerting, and logging to make sure that it's done properly. We're not a data loader. You use us to transform data that's already been loaded into Databricks, and we're not processing your data. All the compute is pushed down to Databricks for optimal performance and security. A typical data engineering pipeline has development silos, where analysts and engineers toss work over the fence to be worked independently. And you end up with this linear flow where only the engineers have access to the raw data, and the analysts have to go through them in order to get their data transformed. And in this scenario, we see a lot of common issues for both teams. First of all, they're using different tools and languages, so they can't really collaborate. And the engineers tend to become bottlenecks because there are typically fewer of them, and they can't control the pace that the analysts are sending in their requests. And then you have recycled deliverables and repeated work. Because the analysts are playing this game of telephone with the engineer where they describe their business needs, the engineer has to go and prioritize that with the rest of their work, and then they come back, maybe it's a week or two later, and deliver that data to the analyst, but maybe they didn't quite get it right the first time because they didn't quite understand the domain the way the analyst would. And then when the analyst tries to take over the transformation steps on their own by using their GUI-based BI tools, they tend to jam a lot of transformation steps into one place, and that slows down their workbooks, and then all that logic is isolated, and it's not getting the benefits of version control, governance, or lineage, or any of those other software engineering best practices. Ultimately, all that work is being done in SQL, and there's no reason that SQL should be excluded from software engineering best practices, other than the fact that many of the practitioners don't come from a computer science background or haven't been given the correct tools to do it. DBT solves that workflow problem by simplifying engineering best practices in a SQL-centric environment, so anyone who knows SQL can work like a software engineer. So now instead of this linear flow, we have access to the data for our analysts and the engineers, and they're all talking SQL so they can collaborate together on their problems and deliver faster. In addition, they have modularity to increase the speed of deployment for their data products, testing, DevOps, and alerts to make the data more reliable, and automatic docs and lineage to improve governance. Another way to look at it is that DBT is offering more access to your data stack. DBT allows your analysts to get involved much earlier in the process, at the point where this raw data transformation begins, rather than at the very end when that transformed data is being served up by the engineering team. Democratizing access to your data pipelines effectively means you have more developers for those pipelines without compromising on flexibility or integrity. This also really helps enable data science teams because now they have this great data foundation that they can search, contribute to, and build off of. And in my last role, the main complaint I got from data scientists was about how much time they spent accessing, aggregating, and cleaning data. But in many of the cases, someone in the business had actually already done all this data cleanup, only they were doing it in Excel or Tableau because those were the tools they were given to work with the raw data. But even when that was known, the logic wasn't portable, and nothing could be automated, so it basically had to be redone from scratch by the engineering team. But the core problem wasn't that no one had done that work before, it was that they were using different tools and different copies of the data. Even after an organization has moved all of its data to the cloud, they find themselves running into this familiar scenario. different personas using different tools and different copies of the data. A common divergence takes place when data engineers and data scientists are given a data lake for their ML and Spark workflows, while data analysts are given a warehouse to do their SQL-based BI workflows. But they don't have to be in different platforms, because with Databricks SQL and dbt, you can bring your analyst team to the Lakehouse. So if you've been supporting parallel workflows to accommodate these two different platforms, you can dramatically simplify your architecture by consolidating down to one. You can stop duplicating pipelines and replicating data and hoping that all stays in sync. You can establish access and governance in one place. You can support fewer external integrations, and you can reduce the number of contracts and risk assessments you have to do every year. And if you're just getting started building your data pipelines, this might seem like a big investment of your time. But as your pipelines increase in complexity, the management of those pipelines becomes exponentially more difficult. Questions that used to be easy to answer, like where did this data come from and how was this value generated, become legitimately difficult to answer. dbt can help you as you scale by cutting your code in half with reusable macros and packages, eliminating silos with Git-enabled version control, catching errors before production with custom data tests, automatically documenting, refreshing, and sharing data lineage, and let your developers actually enjoy the transformation work again. This is really great to have on day one, but becomes pretty much essential as your data gets more mature and you start onboarding more employees, adding new data products, and supporting a mature data product that your stakeholders rely on day in and day out. And a lot of companies have already made this investment and watched it pay off. Today, we have over 12,000 companies using dbt. Over 2,000 of them are on dbt Cloud. And we have over 30,000 members in our dbt Slack community. Having this kind of user base means that we can increase our speed of innovation because people are willing to share ideas and give advice. And no matter what kind of problem you're running into or what you're trying to solve, there's almost a 100% chance that someone has run into that before, solved it, and shared their experience. They might have even published a package so that you can import their code into your project and reuse it. So you should never have to reinvent the wheel. OK, hopefully that all sounds good, but you're probably wondering, how does it work exactly? What does it look like? So we'll get to the demo in a minute, but first we'll explain a couple core principles. In dbt, we're based around models. And in dbt terminology, a model is just a SQL select statement. So you don't have to write the DDL or the DML. Just define what the results should look like, and dbt will handle the DDL at runtime. This lets your users focus on what's important, that business logic, and not the boilerplate code that doesn't add any value to your organization. You might have noticed that we also replaced the table name in the from statement here with a reference function. And that reference function allows us to automatically generate the schema name. So we don't have to hard code schema or table names. We just use that ref function. And it also lets us understand the relationships of these models and build out data lineage as we code. So in the bottom right there, you can see a DAG that's being generated as you code. That can also be found in the documentation. And it shows that dbt knows that stage orders needs to be built before orders, since the orders model was referencing the stage orders model. This means you don't have to automate, or you don't have to maintain your own workflow orchestrator, because dbt can automate the build logic and optimize the order of execution automatically just by understanding what it knows from your code and using that reference function. That also makes your models modular, so you can write your logic once and reuse it many times. And if you have to change something, you only have to update it in one spot. You can also set up multiple environments and have dbt write to the appropriate ones based on context. For example, running this in my IDE would use my development environment. But if I set up a scheduled job, that could use the production environment where the end users could get to the results. And that's possible because dbt separates the model logic, like the SQL select statement, from the configs that tell it how to build, where to build, and when to build. So developers can work in isolated development environments where they can test their pipelines end to end without disrupting other developers, and especially not your production users. Everything we've talked about so far pertains to both our open source tool and our cloud product, but we're going to be using dbt Cloud for the demo, so let's quickly explain what that is. dbt Cloud is our managed dbt offering that combines everything you need to efficiently collaborate on your dbt projects in one platform. It's a browser-based tool that lets you develop, monitor, and deploy your data pipelines. Similar to how Databricks gives Spark developers a much nicer user experience than rolling your own Hadoop cluster, dbt Cloud is going to give you that single platform where everyone can collaborate and see the pipeline end to end. Some other benefits for DB Cloud users are job scheduling and alerting, Git integration that tacitly enforces best practices, hosted documentation, automatic version upgrades, and options for training, support, SSO, RBAC, and more. And connecting Databricks to dbt Cloud is really easy thanks to our natively supported integration. So whether you're coming from Databricks or dbt Cloud, there's a tile in the UI that you can click and get a wizard set up so that you'll be ready to go in just a few minutes. So on the left there, you're seeing the dbt Cloud connector, and on the right, you're seeing Databricks Partner Connect with the dbt tile in there. OK, now it's time for the demo. I like to set this up with a little scenario that might look familiar to many of you. Maybe it's a Friday afternoon and a key stakeholder pings you with a seemingly simple request. In this case, they want to add a region column to their dashboard. But even small updates can be painfully time-consuming because there's a minimum amount of effort associated with any production deployment, regardless of the size of the change. For example, in my last team, we had a no production updates on Friday rule because we didn't want to introduce bugs that someone would have to chase around over the weekend. So clearly, we had a lack of trust in our deployment process that we wouldn't have had if we were using dbt, and hopefully this will show you why. OK, so here I'm starting in the documentation. And this is automatically generated, and you can have it scheduled to refresh whenever you'd like. So if you really want to bum out your data engineering team, you can tell them that they need to go update their documentation, or you can just set up dbt and have it do it automatically. And what we're looking at right here is what's called an exposure. And that allows you to link your data pipeline to downstream dependencies, like this dashboard, or it could be an ML model, or email alerts, or whatever you might be consuming this data for. And this lets you see end-to-end from source to consumption what's going on in the data pipeline. It allows you to add in these details and descriptions. And it also lets you add things to your dashboards directly, such as this status tile. So in the top right here, you can see that the person making a decision based on this dashboard would know just by glancing at that dbt status tile whether their data is current and whether it's passed any data quality tests that you had applied to your pipeline. They can even see when this was last run, so they know that that tile itself isn't stale. So this really lets people have a lot of confidence before they go making decisions, because pretty much everyone's been burned by bad data in a dashboard before. Usually just seeing these two check marks will be enough for anyone to go ahead and make their decisions. But in this case, we see there's one delayed source. So they could go click See Details and open up this additional dashboard in dbt to get a little more information. In this case, we can see it was our orders source that was delayed. And maybe that's no big deal because it's delayed and not stale, or maybe it is. But the important thing is that the stakeholder is getting visibility into the pipeline instead of just having to trust that that dashboard is up to date. Some other things we can see in this little dashboard are 5 sources that are required to build it, the 41 tests that were run to determine whether the data was high quality, and the 9 models that were used. And these are kind of the intermediate steps, those SQL select statements that we're building out our data transformations. And if that's still not enough details, you can go all the way to the dbt job run history and check out the logs. But we're going to come back to this at the end of the demo. So for now, let's go back to the docs and open up our data lineage. So this is also automatically generated. And you can see that on the left, we have our sources. Those are those green nodes. So that's that raw data coming from your source systems being dropped into Databricks. And then on the very right, we have that orange monthly revenue dashboard that we were originally contacted about. And all these steps in between, these blue nodes, those are our SQL select statements, those dbt models that are transforming our data step by step. In this case, the last one in this DAG is the ag orders by month table. So that's what they're connecting their monthly revenue report to. And we can use this DAG to navigate our documentation. You notice it changes a little bit there. And then when we exit this, we're now on our ag orders by month table. So this is also automatically generated. You get this details, the description you can put in your YAML files. But the columns, the data types, that's all automatically generated, what it's referenced by, what it depends on. and even the code that's used. So if you have an analyst who wants to take a really close look at what transformation is being applied, that SQL is right there for them to look at. In this case, we are looking for that region column. So let's search for our docs for the region column. And you'll notice we have a lot of options here. So let's use our DAG again and see what's going to be the easiest thing to apply to our ag orders by month model. In this case, we're already getting data from the customer dimension model right here. So let's make it easy and just keep using that one. So we can navigate to the DIM customers model. And again, all of this is automatically generated. And there's that region column we were looking for. And these documents are accessible to both your developers, your analysts, but also to anyone you want to give read access to. So anybody in your business who can understand this kind of documentation, it's all there for the taking. And up at the top here, you can see the actual database object that was created by DBT here. So if this is the model that I wanted to build a dashboard off of, say, I could go to something like Databricks SQL and just use that table name. And over here on the left, you can see all the other models that were created by my DBT project. But clearly, looking at them in this format is a lot harder to understand than looking at it in that data lineage format. So there's that same data we would see once we start previewing this data. And if you're a Python user, you can use Spark SQL to load this into a data frame the same way. So now you can use your Python libraries to do machine learning or whatever else you want to run on it. And one last way to interact with this data from the docs is to take that compiled SQL and just copy and paste it, and that'll run just like running the table name itself. But this can be a convenient way to test whether something is like an error on the DBT side or the Databricks side. So now that we know where we're going to get that region column from, we can jump into our IDE and make that change. So I'm on that ag orders by month model, and we want to add that region column. And in the middle, you can see we have that DAG right there in the IDE, so developers can use that to understand as they're building out their data pipeline where they're at. They can also use that just like in the docs to refocus on different nodes and open up different files. So if they need to be switching between different parts of their pipeline, that's one way to do it. They could also be using the file directory structure, and maybe in certain cases, having that directory structure where things can be grouped logically makes more sense than navigating the DAG. Up at the top, we have our version control up here, and we'll talk about that more later. Down here is where we put our CLI commands when we want to do DBT runs, DBT builds. And in the middle is our text editor, where we can manipulate SQL files, YAML files, things like that. And you get multiple tabs. So we're going to go ahead and add this region column. And we can preview this data to make sure that it looks like what we want it to look like before we go any further. So the development is really interactive, where you make your changes to the code, and you get to preview it right here on the spot. There's no toggling between different interfaces. Just do everything in the DBT IDE. And this is running with my personal credentials. So if there was the data governance is all handled on the Databricks side. You don't have to replicate anything over on DBT. It's not running as a service account. Anything that I can't access from Databricks, I can't access from my IDE. We can look at the compiled SQL and see that we're using my personal developer schema. So this is how we can all work in isolated developer schemas, and we're not going to step on anyone else's toes if we happen to be working on the same model or influencing data that's upstream of someone else's. And again, that's because we're using this reference function rather than hard coding any table names. So if we go over to Databricks, we can look at the query history and see that this is what I ran, and that it was using my personal credentials. So the next thing we're going to do is do a DBT run. And you can see that they had those suggestions pop up. So it's kind of Google-like, where if you're kind of new to DBT and you're learning the syntax, it'll give you these little helpful hints to pop up and say, we know that you're working on this model, so maybe you just want to run this one model. Because if I didn't select the model, it's going to run my entire pipeline end to end. In this case, I have a pretty small pipeline, so that wouldn't be a big deal. But I only changed one model, so I'm only going to run one. And what DBT run is going to do is take that SQL select statement and wrap the DDL around it. So then it's going to create these objects in my Databricks SQL so that they can be reused and that these things can persist past just the preview state. So down here you can see the details that it's building this ag orders by month table. And if we go down to the logs, we can see that it was using that DDL automatically. So I didn't have to write this as a developer if I'm an analyst who just wants to write SQL. But if you did need to do some optimization where you needed to change that materialization, that's all configurable as well. And again, we're using my personal developer schema because I'm just doing this as a test in my developer IDE. We go back to Databricks. We can see that that is exactly what we saw in the logs, that DDL. That is running as myself. You can see the endpoint that it was running on. You could also do this on interactive clusters, but the endpoints are going to be better price per performance. So now that we've created this object in our Databricks side, we can run a dbt test. And dbt test is going to take any assumptions applied to this data and run it after your model is built. So in this case, we had one of our tests fail. And we can go into the logs and look at the details to see exactly what happened here. So one really important thing to mention about dbt tests is that whether you're putting them in your YAML as a flag or making your own custom tests, it's all just SQL select at the end of the day. So when I drill down to the logs, you can see that this is just another SQL select statement. And in this case, it was looking for unique order month. But when we added that region column, we ended up getting an order month for every region. So that's no longer correct. So that assumption doesn't apply anymore to my model. So I can open up my YAML and make this change so that the new test will be different. And what we're looking at now is our YAML file. So this is a way to add additional context to your models without cramming it all into one file. So the SQL model stays just the SQL select statement. So it's all very easy to understand, easy to add to. And then these additional configurations can be put into YAML, which is a little more appropriate for that kind of data. So right here, you can see the descriptions that we saw in our documentation. That's where all that's coming from. You can put column names in here, but the documentation is going to pull in all the column names regardless of whether you put them in here or not. But if you want to add descriptions or tests, this is where you would do it. So here you can see we had a unique test here. We were just using this simple flag because that's one of the tests that comes out of the box. Easy way to do it. And we're going to change that to a not null. And the other way to add tests would just be to write a SQL select statement and put it in this test directory down here. And then if you're using that ref statement in your test, so say I'm referencing this model, then it knows when I test that model that it needs to use that because, again, we're using that ref function. So it's really tying everything together. So I saved my property configuration. And now I'm going to do a dbt build. And dbt build is just a combination of run and test and a couple of other common commands so that you can have kind of one command to run your whole pipeline. And it's a little bit more efficient because it's going to run a model and then test it, run a model and then test it. So if you had a failing test, it's not going to run your entire pipeline end to end and waste all that compute. It'll know to stop and cut off the compute early to save you some money. So here's our test. It's now working. So we made our update. We previewed the results. It all looked good. It had that region column. We tested it. We found an error, but it turned out that that test was just no longer valid given the change that we were making. So now we want to commit this from our local to our remote repo because having that version control is what allows us to have real data engineering-like capabilities and be able to collaborate and not be in our own little silos all the time. So I click that commit button. And I'm going to write out my commit statement very slowly and hit commit. And in this case, I'm using GitHub. So now that I've committed my local changes to the remote repo, you'll see that this green button turns into open pull request. So this makes version control really easy. So this is how you bring analysts into your workflows, into your data pipelines without losing that integrity. Because things like learning the Git version, or like the Git CLI, isn't really easy. It's pretty hard for somebody who's new to it to come in and not make mistakes. But when you're just asking them to press this button, and then you can configure how that button's going to work in your particular project, it makes things really easy for anyone to get started and not be nervous about doing things like merging their changes to main. So after I hit that button, since I'm using GitHub as my version control repo, it's going to pop open this GitHub screen, and you can see my code here, everything that was changed. And at this point, you can set up all your own rules in your version control environment. So if you have code reviewers, like I used to have to do code reviews for all the data engineering work that was coming in, you can look at this, and it's really easy to decipher because everything is so modular that it's broken down. I can see that this is my ag orders by months model was being changed, and here are the lines that were changed. And I can see that this aggregates.yaml was changed, and that I was just making a change to the order month test. It's really easy to understand because it's all broken up into these logical segments. So I'm going to create my pull request and add another message. Why not? And then at this point, you would probably have a code reviewer. Or maybe you could just bring in your teammates and ask for help if there was no formal review process. But what we're seeing right now is this pull request webhook CI job. So not only does dbt let you review that SQL that was being changed, you can also use a webhook to run a dbt job when the pull request comes in, so that the reviewer not only knows what changed, but it knows that your job can now run end to end and pass all the tests. So they can say with a lot of confidence that this is ready to go to production. And you can add in any other CI test that you can do on something like GitHub through GitHub Actions. We see people very commonly do things like SQL linting as part of their CI workflow to make sure that their SQL is all formatted in the same way. You can enforce that people are putting tests and documentation onto their code before they commit it to main. So you can enforce all of these best practices without having to constantly go back and remind your developers that they're missing something that needs to be there before it goes to production. So in this case, I'm my own Git admin, so I'm just going to go ahead and merge this code. So there it is. We merged my change to production. That took all of 10 minutes. And now this is in our production branch. So the next production job that spins up is going to automatically grab this version of the code. There's no other steps to deployment. Just merge into main, and the next jobs are going to automatically pick up those changes. So now our user who asked for that region column is going to have it, and it only took them about 10 minutes to get it. So now just showing this version control again, I just refresh my Git state, and we're just going to make sure that our remote and local are synced up. In this case, I just did this, so this really wouldn't happen, but just to show you that there's more tacitly enforced Git best practices, just telling you, hey, before you get started, why don't you sync up with the master branch from the remote repo, just so you don't have merge conflicts later. And then this is automatically going to change back to open pull request because there are no unsaved commit changes, but there's really nothing in here. But if I make a change and save it, then that button automatically goes back to commit. So we're right back where we started. And like I said, you can just kind of keep pressing that button until you get your merge request. And it's really simple for anyone to understand. So the next thing we're going to do is look at environments. In this case, anything I did in my IDE was going to work with my developer environment. And each developer can have their own setup for their developer environment. But you're typically just talking about schema and credentials, like who's running that code. But you can have as many environments as you want. And just showing real quickly that this is one way you can set up environment variables. So in this case, I'm showing that you can do a secret environment variable if there was something you didn't want exposed in your logs. You can also just put that in the YAML if you wanted it under your version control. And then if we look at this environment, our production environment, we can see I have 2 jobs running. You can see the run history of those jobs. The CI test is the one that was automatically kicked off when I did my pull request. And if we look at the settings for this environment, you can see some of the settings that we can adjust to this. This is just the ones that are in the UI. You can really go crazy with this in the code, but these are the essential ones that are typically going to be tweaked. You can see we have the schema name, so that's how it knows which schema to write to when we're running production jobs. But you can also change the DBT version. So if you're trying to decide whether you want to upgrade to a new version of DBT, you can use that in your acceptance environment to make sure that everything looks good before you go to production. And you can have it run off of custom branches of your Git repo. So that's common when you're using acceptance if you wanted to have your developers do the pull request to acceptance instead of going straight to production so that you can take a closer look at it and make sure everything's good to go before you promote that to production. Or maybe you want to promote it as part of a larger deployment. So now we're going to go to our run history and check out this weekday job. So now we're right back where we started when we drilled down into that status tile, because this is the job that was generating that data that tells the dashboard whether or not the data is fresh and whether or not it's high quality. And here we can see the settings for a job. Really straightforward. And this can be controlled by RBAC if you don't want everyone to have access to manipulate jobs. Here's where we select our environment. The number of threads is the number of models you want to build simultaneously. That generate docs and run source freshness checkboxes, those are flags that basically tell it that this is the job that we want to determine those values, so those things that we saw in the status tile. The commands I kept really simple. That could have just been a dbt build. And more typically for a daily job, we would see something like run on tags that are, or models that are tagged daily, or you could specify specific portions of your DAG that you want to run. You can set up notifications for Slack channels or email distribution lists. And you can have triggers. This one's just on a simple cron schedule running Monday through Friday. This webhook is how we would do the pull request that we saw in the CI job. And then the API will let you kick off these jobs from anything that'll accept a post command, like Airflow is a very common one to combine your external dependencies. If we dig into an individual run, you can see not just which branch it ran off of, but the actual version of that branch, which is really handy if you detect a bug, but maybe it's like weeks later and you're having to track down exactly when that bug was introduced so you can find the code to fix. And we can jump into our logs here and see that they're just a lot more straightforward than trying to decipher Spark logs. Over here, we can see our project artifacts. So this is going to be a ton of metadata. You can mine yourself, you can send it somewhere else, or you can use our metadata API to grab that metadata and do whatever you need with it. And this is the model timing tab, which is a really great way to see what's holding up your pipeline, finding those blockers, those bottlenecks. So if you saw one model was running for a really long time and a lot of bars were waiting on it, that's a really good opportunity to optimize that code or refactor that model. And you can see we have these 4 swim lanes because this job had 4 threads, so it knows that it can run 4 models in parallel. I have a couple more. I think we're running out of time, so I'll just wrap up. I had a couple more intermediate topics that we don't have time for, but hopefully this gives you the sense that dbt makes the difficult things simple enough for anyone who knows SQL to jump in and contribute to your data pipelines really quickly. But it also gives you a lot of advanced features and time for your advanced users to try out their new ideas, because we're abstracting away a lot of the management of the data pipeline from their day-to-day. If you want to learn more about dbt, we have a booth downstairs in the expo hall with lots of good people to talk to. And we also have 2 advanced talks tomorrow. This was kind of dbt 101. But tomorrow we have our co-founder Drew talking about Python and dbt. So that's going to be a really exciting feature coming later this year. And then we also have a senior solutions architect, Sung, who's doing a talk on machine learning and dbt. So please check those out. And if you want to try dbt yourself, go to getdbt.com. We have multiple ways to try it for free, including our open source version that's going to be free forever. So yeah, thanks a lot for your time.